Right, now let's see how to work with this problem. We can actually start this problem in two ways. All right, we can use a chain rule directly, or we can make it as a quotient rule then use chain rule. Let's work it out. So if at all I use chain rule directly, so the outermost function is the root. All right, so how do you differentiate that? 1 by 2 root whatever is inside into differentiation of whatever is inside. That's how I differentiate root, right? Okay, now what is inside here? There is a squared minus x squared by a squared plus x squared, and this guy is again a squared minus x squared by a squared plus x squared. All right, that's the first way of starting it. I can also start it like this. Okay, if my question is y is equal to root of a squared plus minus x squared by a squared plus x squared, I can use y is equal to, let's say, root of ab, which can be written as root of a divided by root of b. So I am actually splitting the root into 2. All right, so what happens here? I can write this as a root of a squared minus x squared, the whole thing divided by root of a squared plus x squared. Now if I differentiate this, okay, I'm using what rule? U by v rule. All right, later I'll use a chain rule here. I can see that v is root of a squared plus x squared into differentiation of root of a squared minus x squared minus of root of a squared minus x squared into differentiation of root of a squared plus x squared. That is simple quotient rule I'm using, and goes like root of a squared plus x squared the whole squared. All right, so that's one way of doing it. The other way was this, where I use quotient rule for root, and I need to differentiate this guy. Here I will use a quotient rule. So let's do it together. I'm doing the same problem in two ways. Okay, so here it goes like a squared minus x squared by a squared plus x squared, and here I'll be using the quotient rule. This is a u by v rule, so it is a squared plus x squared in a differentiation of a squared minus x squared minus a squared minus x squared into differentiation of a squared plus x squared. Okay, the whole thing divided by a squared plus x squared the whole squared. All right, now what is the differentiation sign? Here it is, and here it is. So the next step, see what happens. I can also put this thing. Okay, this thing will actually go up like that, so it goes like root of a squared minus x squared the whole thing. Oh, this guy is plus, this guy is going up, plus 2 root of, I can write a squared minus x squared. So I made these 1, 2, 3 lines as 2 lines, nothing much. So here I have a squared plus x squared, and I'm differentiating this guy. A squared is a constant, so I'll differentiate as 0, and this is minus 2x. Okay, minus of a squared minus x squared, and here a squared is again a constant, so differentiation of x squared is 2x, and the whole thing divided by a squared plus x squared the whole squared. Okay, that's it. All right, so you can simplify this to get the answer. Open the brackets here, open the bracket, and see what gets cancelled out. In this case, see what's happening. Root of a squared plus x squared remains like that. I'm differentiating this guy. Now here I'll be using chain rule. All right, I started with UV rule, that is quotient rule, but I need to use chain rule now because I have a root function. So that goes like 1 by 2 root of a squared minus x squared into differentiation of a squared minus x squared. That's how it works. All right, minus root of a squared minus x squared into differentiation of, all right, this guy. How do you differentiate this guy? Again, the root function is there, so it goes like 1 by 2 root a squared plus x squared into differentiation of a squared plus x squared. Very nice, simple. And denominator is, I can write a squared plus x squared. I can cancel these two guys. All right, now what's left out? I can see that this is a squared plus x squared remains like that. All right, and I have this fellow is 1 by 2 root of a squared minus x squared. All right, and this guy is minus 2x, simply because this guy is differentiated 0 and this minus 2x, nothing much. Minus of this remains the same thing, that is root of a squared minus x squared remains the same. All right, and now here what happens? I can write 1 by 2 root of a squared plus x squared, nothing to do with this guy. I got to differentiate this. What happens here? Again 2x. Why 2x? Because this guy is differentiated 0, this is 2x, and that's it. The whole thing divided by, I have a squared plus x squared. Simplify this guy, you'll get the same answer as what you have. So this, this is what you have, right? These two guys are separate and these two guys are separate, so I can put a bracket here. There's a bracket like that. Okay, very simple. This minus sign here. Be careful with what brackets are, where to simplify, what to cancel, what not to cancel. So you can say, you can cancel these two guys, cancel these two guys, simplify both the answer. You should get the same answer in both the ends. All right, try doing this yourself.